Hello, greetings, and welcome to a new season of the show. Um, yes, we are looking at a new exam. We're starting to look at a new exam. The department's November 2022 paper 2. And we are getting going with question 3. Yeah, and just as a side note, this channel, the intention behind it was to focus on your level 3, level 4 questions, right, which are more about analyzing and synthesizing and evaluating. I'm literally just quoting my teaching textbook anyway, but really just your non-textbooky type questions. And so I have 2 notes here. So the first is, with paper 2, I tend to do almost the whole exam, end up doing almost the whole exam, especially with department papers. So this is actually the other point. So department papers are structured interestingly compared to IEP papers, because department papers almost like sneak in a punch at the end of each question, right? So you kind of have your straightforward textbooky type questions starting out, and then the last question or 2 is like, whoa, creative thinking, problem solving, where have I ever seen this in my life, right? It's that kind of content. So, and so because I'm trying to get to those questions, to that last bit of the question, I end up having to do the whole question, all the straightforward stuff, all the textbook stuff, just to then get to that, juicy last question. So that's kind of why you might find that with the department's papers, I end up doing more of the exam than with your IEB papers, where there's this idea of section A and section B. Section A is typically then your more textbooky stuff, whereas section B is where, you're kind of stepping out of the comfort zone, stretching the muscles, etc. So that kind of became 2 points in one. Oh yeah, the other thing is with paper 2, the nature of the content of paper 2 is that the problems typically don't look the same way. So if you think of your Euclidean geometry, right? What are the odds that you are ever going to get 2 writers that look identical? Okay, the same could be said of algebra, right? Like quadratic equations, you're hardly ever going to get 2 quadratic equations that look exactly the same across papers. But with quadratic equations, there is like this kind of fixed recipe for how to solve them. Whereas with things like riders, with things like trigonometry, you're given the toolkit, and then you're expected to use any combination of those tools to solve some problem. And that is just the inherent nature of the topics, right? So I find that with paper 1, more of the questions are, just following a recipe most of the time for you to solve them, or at least more of the time, than in paper 2, where just from the jump, the way a diagram is put together could, in and of itself, just feel very new. And that then already feels to me like level 3, level 4, even though it technically might not be. But okay, I'm rambling. Par for the course in this channel. But I hope, I'm making sense. This is me trying to explain 2 things at once. Why I do more of the department's papers than I do from the IEP papers. And secondly, why I do more of paper 2 than I do of paper 1. Or at least it feels like I do. I should actually just look at whether that is factual. Anyway, all of that being said, question 3, let's go. In the diagram, the point A with coordinates 4, 2, the point B with coordinates 6 and minus 4, the point C with coordinates minus 2 and minus 3 are vertices of the triangle ABC. T is the midpoint of CB, which is indicated by CT and TB being equal in length. The equation of line AC is 5x minus 6y is equal to 8. So not in your typical y is equal to mx plus c form, but of course we can rearrange it if we need to get into the standard form. Right, the angle of inclination of AB is alpha. Okay, triangle DCT is drawn such that CD is parallel to BA. Okay, shown by the little arrows. The lines AC and DT intersect at S. AC and DT intersect at S. Cool. The y-intercept of AC, huh? Nice. Okay, cool. Whose equation is that? Right. PF and R are the x-intercepts of DC, AC, and AB respectively. Okay, we have got the picture. I think all the information bar this, I'll just highlight that, but everything else is pretty much on the diagram. Okay, I'll also just highlight this bit in case I forget. S is the y-intercept of AC. Right, calculate the gradient of AB. Okay, so these are 2 points. We know the coordinates, so we're just sticking that into the formula. So the gradient of AB will be the y-coordinate of A or B. I'm going to start with B. Y-coordinate of B minus the y-coordinate of A divided by the x-coordinate of B minus the x-coordinate of A. Alright, and that is negative 6 divided by 2, which is negative 3. Yes, negative number makes sense because our line is giving decreasing vibes, not increasing vibes, so that feels good. Right, and then next one, the size of alpha, which is the angle of inclination of AB. We've got the gradient, so we can then use the m is equal to tan alpha relationship to figure out what alpha is. So we know that, the gradient of AB is equal to tan alpha, its angle of inclination. So negative 3 is equal to tan alpha. Okay, so I'm first going to get the angle of reference, the reference angle, which is the inverse of tan of 3, which is 71,56 blah blah blah. And so because tan is negative, and we know that tan is negative in the second quadrant and in the fourth quadrant, but of course because angle of inclination ranges from 0 to 180 degrees, we're only looking at angles in the first or second quadrant anyway. So we are looking at a second quadrant angle, meaning that alpha is 180 degrees minus 71,56 degrees, and that is roughly oh my gosh, let's try it again. Right, you got it now, you got it. So that is about 108,4 degrees to 1 decimal place. Okay, right, so that's the size of alpha. Time to shrink some things. I started watching Girls 5 Ever, and the theme song is perpetually stuck in my head. We're gonna be famous forever, that's forever. Anyway, fun fact. Huh? Okay, so we've got alpha. Right, coordinates of t. So t is the midpoint of BC, so we're just going to use our midpoint formula. So t, the coordinates of t will be the average of the x coordinates of B and C, and the average of the y coordinates of B and C. Right, so that ends up being 4 over 2, which is 2, and minus 3 minus 4 is minus 7 over 2 will be negative 7 over 2, or negative 3.5. That 7 is not really giving. Let's try that again. Right, and then the last one. The coordinates of S, where's S? The y-intercept of AC. Okay, so, I mean, there's a couple of ways you can do this. We know the equation. We know the y-intercept occurs when x is 0, so in fact, that's probably the easiest way to do it. So, sub x equals 0 into equation of AC, and that gives us 5 times 0 minus 6y is equal to 8. So that's minus 6y is equal to 8, and that is y is equal to 8 over minus 6, which is equal to negative 4 over 3. Just scroll, dummy, just scroll. Right, so then the coordinates of S would be 0 and negative 4 over 3. So that's one way you could do it. Another way you could do it is you could rewrite the equation of AC in standard form. Guys. In standard form, and then I don't want this to go here. I want it to be gone. Anyway. Rewrite it in standard form, y is equal to mx plus c, and then the c would give you the y coordinate of the x of the y-intercept. So that would be another way to do it. Let's just do that quick. 5y, it's such chutzpah. 5x minus 6y is equal to 8. So the aim is to get the y by itself so that we can have y is equal to mx plus c. So, I don't know. My hand is just doing its own thing. So then we'll have minus 5x plus 8, right? If you minus 5x on both sides, and then divide through by negative 6. So that will be minus 5, HEI, plus 8 over minus 6, right? And that would be y is equal to positive 5 over 6x minus 4 over 3, right? So then we're still getting that minus 4 over 3 as the y coordinate of the y-intercept. So, yeah, there's that as well. Okay, right, let's double check answers. Love me some certainty, love it. So we have minus 3 for our first answer, 108,443, 2 decimal places. Anyway, yes. 2, hi man, software update. 2 and negative 7 over 2 for the coordinates of t, and the coordinates of s are 0 and negative 4 over 3. Perfecto. So we now proceed to the next question with knowledge. Okay, cool. That is for this line. Anyway, determine the equation of CD in the form y is equal to mx plus c. CD, where are you? This guy has the same gradient as this guy because they're parallel. And then we've got a point on the line so we can figure out what c is. Cool, let's do it. So the gradient of CD is equal to the gradient of AB because AB is parallel to CD, and so it is equal to minus 3. Therefore, equation of CD looks something like y is equal to minus 3x plus c. So then we sub in the point C, and we have minus 3 is equal to minus 3 times minus 2 plus c. Minus 3 is equal to 6 plus c, and therefore c is equal to minus 3 minus 6, which is minus 9. And yeah, that is, in conclusion, the equation of CD. Agreement? Agreement. We move. Right. So I'm not going to fill everything. I'm going to fill everything in. I'm probably going to need this diagram. I'm probably going to end up erasing so much of this stuff so that I can scribble. Anyway, calculate the size of DCA. DCA. This guy. Okay. So what I immediately see is that we have an alternate angle situation going on here. So this is the same as this. And what do we furthermore know? Well, I think we could find out the size of this angle because it is the angle of inclination for CA, and we have the equation for that line. So we could find its gradient, find its angle of inclination. We know what this is, and then using exterior angle of this triangle, we know that these two added together have to give me this. So I am going to start by finding this out, and then that will give me this, which will then give me that. So let's do it. So I'm going to rewrite 5x minus again in standard form, just work it out officially. Well, not work it out, rewrite it in standard form officially. So then that means tan of angle AFR, okay, which is this angle, is equal to 5/6, the gradient of the line AC. Positive tan value, so we're looking at our first quadrant angle, which is great. So that is going to be inverse of tan of 5/6, which is Okay, first of all, I'm going to store this guy because we're going to need him. Okay. Right, so we now know the size of this angle as well. So now we're going to find the size of that angle. And we will find it by saying angle A, I was going to call him A is equal to 108,43 blah 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 minus 39,80 blah blah blah, and the reason for that is exterior angle of triangle AFR, right? And that gives us I don't think I need to store this one. So recall that first guy minus the one. What is it? What is it? I see. Okay, so now we have A minus that number. Yes, that is correct. And that is 68,62 blah blah blah. Right? And so finally we can say what this is, right? Because alternate angles. So therefore, angle DCA is equal to, or we can two decimal places 6,3, and that is because of alternate angles CD parallel to AB. Okay, right. Let's see if the memo's feeling it. The memo is feeling it. They rounded things off wrong, right? Yeah, but anyway. So let me move this elsewhere. Okay, what I will do at the end is just look and see if they did it. I'm not really interested. Not today. Any other day. Today is not the day. But yeah. Any other day. Not any other day. Maybe some other day. Oh no. Okay, so that's the first bit of the question done and dusted. Right, so then on to the next one. The area of POSC POSC. What kind of shape is that? My goodness. So we know that it's not a trapezium because these two are not parallel. This is a vertical line. This is a line with a gradient of -3. These two are also not parallel because this is not a horizontal line. So this is not a trapezium, and therefore it can't be any of the relatives of trapezium, the descendants, parallelogram, rectangle, all that stuff. So this is just a weird shape. Joke not detected. So okay, what I am seeing of this shape is there's this triangle, right? FPC, okay? And then there's this smaller triangle, FOS. If you take this little triangle away from big triangle, then you're left with this weird shape. So that's how I think I'm going to work out the area of POSC. I know how to work out the area of triangles. So that's what I choose. That's what I choose. Otherwise, another way we could do it is we could say, well, there's this triangle, and then take away this triangle so that you get this bit, and then work out the area of this triangle, and then you get that bit, and then you add them together. So that's another way to do it. Let me think about approach number 1 first. So to work out the area of this triangle, what would I need? I would need we have the equation of this line, so I can find the x-intercept. We don't have the equation of this line. Oh, we do over here. So I can find the x-intercept. So then I know how long this is, okay? And then I know how long that perpendicular height is, because -3 y coordinate, so this is 3 units below the x-axis. So working out the area of that triangle is easy enough. Okay, so then let's look at this little triangle here. Yep, we can easily find f. We know what s is, and then we can do half base times height here as well. Okay, so that's straightforward. Well, now that we have a plan. Let me, out of curiosity, look at this other scheme that I had in mind. So for this one, we would need the equation of this line so that we could find the coordinates of this guy. And I don't know how we would get this equation. Oh, we've got 2 points. So we could get the equation of that line, get the coordinates of D by finding the point of intersection between these two. And then once we have the x-intercept also, we could find the length of this base, and we would know the perpendicular height because we would have the coordinates of D. Oh yeah, that's a lot of work anyway, but yeah, it could be done with much pain. Alternatively, maybe we could see if we could use some trig. That could work, because we'd have these 3 points. Those are easy to find, and then we can find the angle of inclination of this line, because we know, well, it's actually the same as this one because they're parallel. So then we could use the area rule to figure out the area of this triangle, and I think we could pretty much do the same. Anyway, okay, fine. You know what? I'm just going to stick with original plan. So just to go over the plan again, we want to find the coordinates of P. Okay, so that is step 1. And then we want to find the coordinates of F. Maybe I should do this in another color. Yeah. Okay, then we want to find the coordinates of F. That is step 2. So then that's going to give us this length as step 2. Okay, then we know how long. Oh my word. Oh. We know how long this is because of that y coordinate over there. So we are able to figure out the area of the yellow triangle as our step 4. Then, as our step 5, we would know how long this is. Okay, we know how long that is, and then we can figure out the area of this little bit, and then we minus this from this, and then we have POS. Alright, so let's do that. So step 1, we are finding the coordinates of P by making y equal to 0 So, ooh, ooh, ooh. Okay, and therefore minus 3 is equal to x. So therefore the coordinates of P are minus 3, 0. Next up, we are finding the coordinates of F, which lies on AC, x-intercept of this guy. So again, we will find that by making y 0. And therefore, oi, the coordinates of F will be 8 over 5 and 0. Okay, so we got that now, which then gives us the length of PF. Yo, wat gaan aan? Okay, 8 over 5 minus 3. So that is 4 and 3/5. Wait, okay, let's do this. 8 over 5 plus 3, which is the same as 15 over 5. So that is 23 over 5 units. Okay, so we've got that now. So now we can work out the area of this triangle. Okay, so therefore the area of triangle PFC is equal to half the base times the perpendicular height, and that is 69 over 10 square units. Okay, right, so that is this triangle here, and this little triangle. So we are going to find area of triangle OFS is equal to a half, and this distance is what are the coordinates of F? 8 over 5, and this distance is 4 over 3. Okay, so that ends up being 32 at the top and 30 at the bottom, which is the same as 16 over 15, right? So that's the area of little triangle. And so the area of POSC will be equal to the area of the bigger triangle, which is 69 over 10, minus the area of the smaller triangle, and common denominator is 30. Gulp. 69 times 3 is 207, I think. Okay, and that is 175 over 30, which I don't know, divide by 5, top and bottom, 35 over 6 square units. Okay, and now to cordon all of this off from all of that. And that is my answer. Let us see. Decimals, I don't know. Yes. We arrive at the same answer. Fantastic. And out of curiosity, let's look at how else they go about it on these streets. So I'm just going to be quiet for 2 seconds and try and digest what's going on. I did say I don't want to do this. There are lots of alternative ways to do it. I am not going to look at them, but they are fun. They are fun looking, so I encourage you to look in the memo and have a feast. Cool. Catch you another time for another chat.